Data wrangling is an essential first step of any data analysis work. It's the process of preparing your data for analysis by cleaning, reshaping, and transforming it into a structured and coherent format. Pandas provides us with a comprehensive and intuitive toolkit for performing these tasks efficiently and effectively. With that said, let's do some data wrangling, y'all. All right, yeah, I heard it. That was pretty bad. Real-world data is messy. In fact, it's not uncommon to receive a data set that has a series of missing values, incomplete records, duplicate records, inconsistent attributes, or other unnecessary noise that you have to manage. For example, the rewards dataset that we worked with in a previous video contains a lot of messy and incomplete records. So to begin the process of data wrangling, let's import a fresh copy of that data into a new data frame. To follow along with me here, I've included a copy of the file in the video description below. Just make sure that you save the data file in the same directory location as your current Python or Jupyter Notebook file. And so once we have the data loaded into a new data frame, let's review the first 20 records to get a better sense of what we're dealing with here. So again, just an overview of this data set. It is data with each record representing an entry for a user that is enrolled in a rewards program. And we have different attributes such as their birthday, city, state, zip, and then information about the points that they've earned and spent, the date they joined, the date they were last seen, and then we have this tags column here. Now, right out of the gate, we see several instances of missing data as indicated by this NaN value, which stands for not a number. There's also a bunch of inconsistent value formats entered into, for example, the state column. We can see that in some cases we have the full state name, and in other cases we have the state abbreviation. So we're going to want to fix those issues. We also have this tags column here that stands out, where the formatting of the data is a bit strange. We can see there's different values and they're all separated by this pipe character. So we may or may not actually want to use that data. So since data wrangling is a multi-step process, let's address these issues one at a time. Now, when it comes to correcting missing values in your data set, you essentially have three options. First, you can fill in the missing values with some default value. So for example, perhaps you enter a 0 for any missing numeric data. You can also work to fill in all the missing values with accurate and complete values. Alternatively, you can just say, let's drop all of the records that contain missing values and analyze the subset that is complete. Now, which approach you take really depends on a few important factors, such as the type of analysis that you're interested in performing, looking at which attributes are relevant to your objective, thinking about the number of records that have missing values present. You also want to consider what's the value, whether it's monetary or otherwise, of actually replacing the missing data. And from that, you have to think about what's your access to alternative data resources to fill in that missing data. So there's a lot of factors to consider, but ultimately it's going to come down to really time. How much time are you willing to invest or have available to invest in filling in these missing data values versus just dropping the incomplete records and analyzing a subset? So to make an initial assessment, we can get a count of the total number of missing values in each column of our data set using a combination of the isNA function and the sum function. So the isNA function is used to identify missing values, and what it's going to do, if we go ahead and refer to the rewards df here, we'll just type in isNA and run that. It's going to create a data frame that's the exact same size as our data frame. And for each value, it's going to replace it with either true or false. It's going to be true if the value is missing and false if the value is present. And since in Python, true equates to 1 and false equates to 0, we can go ahead and use the sum function here to actually get a count of how many instances of true are present here. So what we'll do is we'll just take the same code that we wrote up here, and I'm going to create a new variable called missing value counts, and I'm going to set it equal to rewards data frame.isNA, and then I'm just going to append the sum function. And what that's going to do, we'll visualize this, is it's going to count the instances of true in each one of the columns and report that value here. So we can see here that in the case of birthday, city, state, and zip, they have a lot of missing values, but last seen doesn't really have that many, so perhaps we could handle that. So to get even a better idea, let's go ahead and convert those numbers to percentages. I'm going to say missing value percentages, and we will just take that missing values count and we'll divide it by the length of the rewards data frame, and then I'm going to multiply that by 100. And so we can see here that we have, high percentages of missing values for those birthday, city, state, and zip columns, but the last seen column, it actually looks like it only has about 3% of its values missing. So here is a potential candidate for us to actually fill in missing data values with maybe a default value. So let's look at this column a little bit deeper and try to get an idea of what we could do with it. So what we're going to do is we're going to reference rewards data frame, and then I'm going to pass in the value of that column name. And we can see here that the last seen values are in the format of a timestamp, but their current data type is actually just a generic object. And so we're going to want to convert this to an actual datetime data type using the toDatetime function in Pandas. This function is really flexible and it can handle a wide variety of different string formats representing dates and times. So what I'm going to do here is I'm just going to, again, reference this column, and I'm going to set it equal to pd.to_datetime, and then I'm going to pass in that column here. And what it's going to do is it's going to take all the values in that column, it's going to process it through this toDatetime method, and it's going to reassign the values to that column. And so if we actually visualize this again, we will see that the values are now in datetime format. Now, with them in that datetime format, I can now treat them as dates and times. And so I'm going to go ahead and run the max function and the min function against this column to kind of see what the range of dates that we're dealing with is. We'll just say max and then also min here. So now that we know that the range of dates is between, looks like October 12th, 2020 and July 1st, 2022, let's just make the assumption here that any missing values can be set to that earliest date in the range, meaning the minimum. So to accomplish this, we can use another Pandas function that is fillNA. And fillNA is going to replace any missing values with a specified value. And so in this case, we want to fill it in with the minimum date. So I'm going to, again, refer to that column, and I'm going to call the fillNA method here. And again, I'm using the terms method and function interchangeably. I know it's a bad habit. They are related to one another, but we understand that a method is a function within an object or a class, and a function itself is a standalone procedure. So again, all methods are technically functions, but not all functions are actually methods, and we do use those terms interchangeably. So anyways, we're going to call the fillNA, it's a function, but technically it's actually a method. And we're going to specify that the value that I want to fill is actually this rewards data frame minimum date. And I want to do this with in place equal true. And so you're going to see this in place parameter a lot as we work through some of these different functions and methods. And that's because anytime we're trying to make the change to a data frame without creating a new copy of a data frame, we want to use that in place equals true to make that change. So now that we've done that, let's go ahead and rerun our missing value counts just to confirm that the last seen column now has 0 missing values. Now, our next step in this process really depends on the goal of our subsequent analysis. For example, with birthday, city, state, and zip all having a very high frequency of missing values, they really aren't that useful to us if we're looking to conduct detailed analysis on those attributes specifically. Alternatively, we could say, let's just drop all the records that contain any missing values and see if that leaves us with a sample that's sufficient enough to conduct some level of analysis. So let's go ahead and try that using the dropNA function that is in Pandas. So we're going to want to retain our original data set. So let's assign the resulting value of dropping all these incomplete records to a new data frame variable. And I'm going to call that rewards data frame sample. And we're going to set that equal to our rewards data frame. And then I'm just going to call the dropNA method here. And then let's go ahead and just paste this here so we can visualize what that effect looks like. So if we scroll to the bottom, we'll see that we're now left with 172 rows from our original data set. So it confirmed that we did in fact drop the missing values, and we can double check that by rerunning our missing value counts, this time on that sample. And we can see here that we have no missing values in any of these columns, and we're left with that 172 records. And considering that we started with well over 7,000 records, this is a much smaller set, but I think that it's usable enough to do some analysis. So now that we've handled the missing values, let's focus on the messy data in our data set. And I'm going to start by dropping the tags column because I don't really think we're going to use that much in our analysis. And so after we drop the tags column, we'll proceed to clean up some other things here. So to drop a column, you will use the drop function. So I'm going to, again, refer to our new data frame, which is rewards data frame sample. And I'm going to set that equal to itself. And I'm going to call this drop method. And I want to specify what columns to drop. So there's a columns parameter, and make sure you don't forget there's actually an S there. And then we'll go ahead and reference the tags column. And then we'll visualize that just to confirm that that change was made. And so we can see now that before we had that tags column here, that has now been dropped, and we're left with these 10 columns right here. So now that we've done that, let's go ahead and start cleaning up some of these values in the columns that we're keeping. Starting with the city column. So let's go ahead, and what I want to do here, when you're working to correct inconsistent value formats in a column, you want to go ahead and get a complete list of the unique values in that column so that you can kind of see what we're dealing with here. So let's go ahead and create a variable that's going to hold a list of these unique values. Well, it'll actually be an array. So we'll go ahead and say city underscore unique values, and we'll set it equal to our rewards data frame sample. And then I'm going to reference the city column specifically. And when you're referencing a column or a series of a data frame here, there is a method you can call that is unique, and that returns an array of unique values from the data frame, omitting any duplicate values. Now, if I just run this right now and visualize it, it's going to be just a mixture of these values, and it's gonna be a little harder to kind of assess if we have any inconsistent values. So it's gonna be helpful to sort these values before we actually display them. So let's go ahead and apply our sort method. And so that looks a lot easier to interpret. Now, printing out a sorted list of these unique values for the city column highlights some inconsistent field value formats and some other issues here. But right off the bat, what I see, if I go down to the bottom, I see a lot of different instances of the city Winston-Salem spelled in different formats with different issues here. So what I want to do is I actually want to clean this up and replace it with the correct formatting and spelling of that city. And to do that, I can use the replace function. And so the replace function is used to replace specific values with another value. And this is really useful when we're cleaning and trying to transform our data set. So what we're going to do here is, again, I'm going to refer to the city column, and I'm going to call the replace method. And in the replace method, the first parameter is the values that you want to replace. And so in our case, we're going to create a list of all of the different variations of Winston-Salem that are listed here. So I'm just going to copy all of these just to make my life easier. I don't need to type this all out. So we'll just copy all these values, and I'll put them in here as a comma separated list. And you can see the brackets there indicate that I am in fact using a list. And the second parameter in this method is the value. So I'm going to specify that I want the spelling to be Winston-Salem, where W and S are both capitalized. And I want to make this change in place. So in place equals true. And remember that if you're wondering what are the different parameters that you have for different methods, you can always refer to the Pandas documentation, and it'll give you a complete list of those parameters, also including some sample usages so you can get some practice with it. So we can go ahead and run that. And then another problem that I noticed was that there was a series of leading and trailing spaces in some cases. So for example, up here I saw that Belmont had a trailing space, and there's a couple other instances of that throughout if you look at this very closely. So if I want to remove any leading or trailing spaces, we can use the strip method that we learned for working with strings. So let's go ahead and refer to that. So I'm going to, again, reference my city column. I'm going to set it equal to itself. And then because I'm not creating an instance of a string, I will reference the string class directly, and then I will reference the strip method. And what this is going to do is any instances of leading or trailing spaces that are present in these cities, it will go ahead and remove those for me. I also noticed that there were some casing issues throughout. For example, if you look up here at Manhattan Beach, I can see that B is actually not uppercase. And so typically with cities, they follow a title casing. So to fix that problem, what we can do is we can apply another string manipulation method, which is the title method. So I'm just going to copy and paste the code we just ran, and I'm going to replace strip with title. And once we finish this, let's go ahead and rerun our unique values here to kind of look at our list. And so reviewing this list now, we can see that in the case of Winston-Salem, the issue's been fixed there. And I don't really see any leading or trailing spaces. And it looks like the title capitalization of all the cities is fixed as well. So now that we've addressed most of the issues with city, let's go ahead and follow the same process for state and zip. So I'm actually just going to come up here and copy this code here. And I'm just going to change this to state. And then I will go ahead and sort those and visualize them. I'll also want to change this to state. And let's go ahead and see what we have here. So it looks like the state column currently has a mixture of both state abbreviations as well as state names. Now, what you can do here is go through and either replace the full state name with the abbreviation or the abbreviation with the state name. And so to accomplish that, I went out and did a quick web search and I looked for a Python dictionary of state abbreviations. And I actually found this on a website and just copied and pasted it. So you can see it's a complete dictionary with all of the US states and territories listed in their full name along with their abbreviations. And so what we can do is we can use this and build a loop that will go through every entry of our data frame and compare it against this dictionary and either replace the state name with the abbreviation or the abbreviation with the state name. So either one of those can be easily accomplished. And what I want to do is go ahead and replace any instances of the state name with the abbreviation. So for example, New York will be replaced with NY, North Carolina will be replaced with NC, and so on. So let's go ahead and write a for loop to do this. So we're going to say for, and we'll give a placeholder variable called state name in the US state to abbrev dictionary. We want to replace each state name with the abbreviation. And so we're going to reference our rewards data frame sample and specifically the state column. So it focuses just on that. And we're going to use our replace method again, just like we did with the city names. So our value to replace is we want to replace the state name, right? So we're going to say state name with the value from this dictionary. So again, the state name is currently the key as it's the first column of the dictionary, and the abbreviation is the value. So we're going to refer to the US state abbreviation dictionary, and we'll pass in the state name because that's actually going to be the key to look up that value. And of course, we want to do this in place. So we'll say in place equals true. And so this line of code here, what it's going to do, it's going to iterate over all of the state names in this dictionary. And anywhere that it finds that state name in our rewards data frame, it's going to replace it with the value, which is actually the abbreviation. And now we can go ahead and rerun our unique values on the state column to see if that change has actually been made. And it looks like it has, right? So we have no more instances of the state names there. We just have the abbreviations that are left over. Now, if we wanted to actually include the full state name along with the abbreviation in our data set, that is something we can accomplish by merging the two data sets together. Now, merging in Pandas is a very common task, and it simply involves combining multiple data sets into a single data frame. And to do this, you're going to be matching up some values, right? So in this case, we want to match the values of the state abbreviation in our rewards data frame with the state abbreviation values in that dictionary. But before we do that, we actually need to convert that dictionary into a data frame so that Pandas can work with it more easily. So what we'll do is we'll actually refer to this state abbreviations dictionary. So I'm just going to copy and paste the name. And we're going to create a new data frame, and we can call it states data frame and set that equal to PD data frame. And there's a couple of different ways that you can accomplish this, but one of the easiest ways is to convert this dictionary to a list. And so we can use the built-in list function that's part of Python, and I can pass in the dictionary, and then I can use what's called the items method in the dictionary. And so what the items method is going to do is it's going to pull out all of the key value pair items in the dictionary and then convert it to a list that has 2 columns. And so in the data frame, we're going to want to tell it what we want the column names to be. So we'll reference the columns parameter here, and we'll set this equal to the orientation of the dictionary. So right now, the first column here, which is the key, is the state name, and the second column is the state abbreviation. And since I want to match it up with the state column in my rewards data frame, I'm going to call that state abbreviation column just simply state. So our first one will be state name, which will be the full name. And then next, we have the state column for the state abbreviation. Now, if we want to go ahead and run this and visualize it, we will just look at the first 3 rows here using the head method. And so we can see here the first few records, and it does look like our conversion from dictionary to data frame worked just fine. And so now we're ready to go ahead and merge our rewards data frame with our states data frame. So to accomplish this, we're going to use the PD merge. So we'll go ahead and say rewards data frame sample equals PD merge. And when you're performing a merge, the first data frame that you specify is referred to as the left data frame. And so that's going to be our rewards data frame. And the second data frame is going to be what's referred to as our right data frame. And this is similar to doing joins in SQL databases. If you've ever done that before, it's very similar. So we have our left data frame and we have our right data frame. And we want to tell this merge method how we want to combine them. And we want to combine them on, and so there's an on parameter here, the state column. And so what I'm doing here is I'm trying to match up. We have a state column in the state data frame that contains the state abbreviation, and then I have a state column in my rewards data frame that has the state abbreviation. And so I want to combine the 2 data frames based on that value. But there's also a parameter for how you want to combine them. You can do what's called an inner join, outer join, a left, or a right. And so the best way to explain those, I have an explanation right here of each, but it's a little bit easier to understand if you visualize it. So basically, let's start with inner join. So an inner join is going to take all the records that are at the intersection of those 2 data frames. So basically, it's only going to take the unique combinations that exist in both of those data frames and combine them, which doesn't sound like what we want to do. On the other end of the spectrum, we have the outer join, which is going to take all of the records in both the left and the right data frame and combine them together. That's also not really what we want to accomplish. What we're looking to do is we're looking to focus on our left data frame, which is the rewards data frame. And we want to retain all the records in that left data frame and just append, or we're merging in the records that are in the state data frame, which is our right data frame. We want to merge those in. If you want to do the opposite, then you would have the right join here. And in a right join, in that case, basically we would just be pulling over a small subset of records from the rewards data frame into our state data frame, which also doesn't really make sense. Now, if you're confused about what the net effect would be if you did some of these other settings, if you did an inner join or an outer join or a right join, you can go ahead and play around with it, right? So in this how parameter, I'm going to set this to left because that makes the most sense for what we're trying to accomplish. But if you wanted to see what the effect would be of doing an inner join or an outer join or a right join, you can do that. Just go ahead and set this parameter to one of those, run it, and then view what the net effect is of that. But I know for our instances here, we simply want to do a left join. Since we now have both the state name and the state abbreviation in our data set, let's go ahead and change this state column heading to actually state abbreviation. So to do that, we can use what's called the rename method. So we're just trying to go through a bunch of different pandas methods just to understand how they work when you're doing data wrangling. So we'll go ahead and reference our rewards data frame sample here, and we're going to call the rename method. And basically what you do is you tell it the columns that you want to rename, and you give them as key value pairs. So we're going to say columns here, and we're going to set it equal to a dictionary, where the key is going to be the current column name, and the value is going to be what I want to change that column name to. And so I want to change it to state abbreviation. And of course, I want to make that change in place. So I'm going to say in place equals true. And we can go ahead and just visualize the first few records of this to make sure that our change actually did work properly. And so we can see here that has now been renamed to state abbreviation. Now, if we also wanted to rearrange our columns so that state name and state abbreviation are next to each other, we can do that pretty easily using a combination of two methods, the pop method and the insert method. So what we're going to do here is we're going to pop out this state name column, and we're then going to insert it in next to this state abbreviation column. So let's go ahead and take a look at what that looks like. So our first step here is we actually have to pull that column out. So I'm going to give it a variable name for that series. Let's say state name column, and I'm going to reference the rewards data frame sample, and I'm going to call the pop method, and I'm going to pass in the value state name for my column. Next thing I want to do here is I want to insert it. So we're going to say rewards data frame sample dot insert. There are three arguments that we're going to need to specify. First, we want to specify the position of where we want to insert this, which is going to be right next to state abbreviation. And so it looks like that is index 0, 1, 2, 3. That's the position of that column. And then I want to make sure the column is called state name. And then the data, of course, is my state name column series variable that I created up here. And so let's go ahead and run that, and we'll visualize the first three rows here. And so we can see here, state name has been inserted right there in the third column position next to state abbreviation. So now that we have the state values all cleaned up and organized in our data frame, let's move on to our zip code. And so I have the code here for listing out the unique values, just like we did with city and state. So I'm going to run that. We see a couple interesting things. Now, as expected, the zip column contains a mixture of different values, different formats that is. We have some zip codes that are longer than others. And so we want to go ahead and standardize this format. Now, since most zip codes in this list are the 5-digit format, which is the most common, let's use that as our baseline format. And I want to truncate any zip codes that exceed 5 digits, like this one right here. So we're just going to cut that off. And to accomplish that, we can use string slicing. It's very common to use string manipulation methods when you're performing data wrangling work. Let's go ahead and reference our rewards data frame sample, and specifically the zip column. And we're going to set that equal to itself. And we're just going to use the string slicing approach. So we're going to reference the string class. And then I'm going to reference, I want all of the digits from the beginning up until the 5th, which is actually at index 4. So I'm going to put index 5 here, and that will include the digits in position 0, 1, 2, 3, and 4. And that's my first 5 digits of the zip code. Now, since an individual city may have several different zip codes, it makes it very difficult for us to go back and correct any incomplete codes. For example, you can see here that there's codes with less than 5 digits. So what I'm going to do here, since there's really no reasonable way for me to go through and figure out what the correct zip code is, I'm just simply going to drop any records in the data frame that have zip codes less than 5 digits. Now, to accomplish this, this is a little bit more involved because we're going to have to use the string length function and a concept known as Boolean indexing. So Boolean indexing is a very powerful feature that exists in Pandas that allows us to filter data in a data frame or a series based on a Boolean condition. And then we can use it to select rows where specific conditions are true. It's particularly useful for querying and subsetting a data based on a specific criteria and allows us to do some pretty complex manipulations of a data set. So to accomplish this, we first want to create a Boolean index based on the zip code length of 5 digits. And so any records with a zip code less than 5 digits will be assigned a value of false by creating this Boolean index. So what we're going to do here is we're going to create our Boolean index. I'm just going to call this zip code Boolean index, and I'm going to set it equal to our zip code column. And I'm going to reference again the string class because I want to use the string length method. And I'm going to say I want the length where it equals 5. So again, this is a Boolean condition. I'm saying where the zip code column length of the string is equal to 5 digits. And so let's go ahead and display what this Boolean index looks like. And so you can see here, it is a series where it's gone through every value in the zip code column and assigned true if the length is currently 5 and false if it's otherwise. Now we know there's no zip codes left that have greater than 5 digits because we went ahead and removed those. And so any values here that are left that have a value of false are going to have less than 5 digits. So to apply the Boolean index and select only the rows where this condition is true, we simply want to pass a reference to this Boolean index as if it was a column name in the data frame and assign the result back to our original data frame. So what we're going to do is I'm going to say our rewards data frame sample equals the rewards data frame sample. And just like the Boolean index was a column in our data frame, I'm going to pass that in between those two brackets. And so what that's going to do is actually apply the Boolean index to our data frame. And if we want to get the unique values of zip again, I'm going to go ahead and just copy and paste what we have up here so we can review that. We will see that if you go through all of these, we only have zip codes left that are exactly 5 digits, which is exactly what we're trying to achieve. Now, obviously we dropped some records. So to determine how many records we actually dropped, let's go ahead and get the length of our data frame. So it's gone down now to 155, which is still a usable sample size. Now, before moving on, let's go back and quickly review the rest of the city names. As you're working through the data wrangling process, it's important to go back and periodically review your progress. As records are cleaned or dropped from your dataset, you may start to notice issues that you didn't see before. For that reason, data wrangling can kind of feel like a game of whack-a-mole, where when one problem gets fixed, another problem might pop up. For example, there are actually 2 city names here that stand out as possible anomalies in the data. And that's this city here that says G and the city LMAO. Now, a quick web search can confirm that there's actually not any US cities with these names. So these incomplete or inaccurate records can be dropped using Boolean indexing as well. So to accomplish this, we're going to reference the rewards data frame sample, and we're going to set it equal to itself. And then within that, we're going to reference the rewards data frame sample column for city. And we're just going to create this condition where I'm going to say, I want to select all of the city rows that do not equal G. So instead of specifically dropping the G row, we're basically saying select all of the rows that don't equal G. And so we want to do the same exact thing here for the city LMAO. And that will go ahead and drop those from our data frame. And we can check to make sure that it actually did drop them correctly if we look at the length of our rewards data frame sample once again. While the data wrangling process will vary from dataset to dataset, the steps we just worked through covered a lot of the common issues that you're likely to encounter. In our next video in this series, we'll explore how to work with datetime data in Pandas. As always, if you've enjoyed this video, hit that like button, subscribe, and click that bell so you don't miss out on any future lessons or videos.